Hello, my name is Jason Mocan, and I'm going to talk about the differences in the cerebral makeup of savants. What is the purpose of this? The purpose of this is to provide an analysis on Ramachandran's reflections and his predictions on what a savant's brain ought to look like physiologically. What are savants? Savants are people affected with a mental disability such as autism or mental retardation, things that could derive from genetics or brain damages or lesions or just external events. Usually savants exhibit exceptional skills and brilliance in limited fields such as mathematics or music. A few savants consist of Kim Peek, Leslie Lemke, and Daniel Tammet. Kim Peek has read up to 12,000 books and remembers everything about them. It's said that he can read 2 pages at the same time, with his right eye scanning the right page and his left eye scanning the left page consecutively. Yet he can hardly button his own shirt. Leslie Lemke has learned Tchaikovsky's Piano Concerto in 15 seconds after simply listening to it on the TV, yet he had his eyes removed after birth and it took 15 years for her to walk. Daniel Tammet has recited pi up to 22,514 decimal places and speaks 11 languages and learned Icelandic within a week, as shown on Good Morning America. How does Ramachandran explain the phenomenon of savantism? First of all, he says that intelligence is a mix of mental traits rather than generalized one intelligence that can be taken from an IQ test. This seems to support the multiple intelligence theory, which says that there's many different types of intelligences which can be measured independently. Ramachandran also considers the possibility that savants suffer early brain damage before or shortly after birth. He considers the possibility that their brains undergo some sort of remapping, as seen in phantom limb patients in previous chapters. In savants, one part of the brain may for some obscure reason receive a greater than average input, or some of their equivalent impetuate to become denser or larger. And for his example, he uses the angular gyrus. When the angular gyrus is damaged, it's known that it's known to disable simple math knowledge. For example, the pilot who can subtract 7 from 100 from previous chapters. Going back to the paternal or neonatal injury that leads to the rewiring and compensation of the left angular gyrus, he states that the doubling size of an LAG doesn't necessarily equal to 2 times math ability, rather than a logarithmic or 100-fold increase in mathematic ability. Going upon this assumption, one would suggest that a math-oriented savant would have a larger left angular gyrus, while as an artistic-oriented savant would have a larger right angular gyrus. What do we know of the left angular gyrus? We know that it's reliably activated across a wide range of semantic meaning and logic-oriented tasks, and it consistently reports of components of the default network, which is deactivated during all goal-oriented tasks. We also do know that there's a small overlap between the semantic system and the default network in the left angular gyrus, and this overlap would define a reliable functional landmark that can be used to segregate functional subdivisions within the angular gyrus. To compare Ramachandran's theory to current researches that have happened after the publishing of his book, we'll look at the experiment of a 63-year-old autistic savant who has had a high-resolution magnetic resonance imaging test being done on him. Within the high-resolution MRI, the regional and compartmental brain volumes in acetyl aspartate, choline, creatine, glutamate, and Y-aminobutyric acid concentrations were measured. Fractional anisotropy values, white matter bundle volumes, and axial, radial, and mean diffusitives were also calculated within this experiment. That being said, this experiment looked not only at the the mass and the weight and the size of the brain in different hemispheres, they took a pretty extensive look at what this brain looks like in comparison to the normal human brain. After comparing his results to the average adult male, Corrigan came to the conclusion that there was a larger cerebral volume than the average adult male. The corpus callosum was intact and normal. The right hemisphere was 1.9 larger than the left. The right amygdala was 2.4% larger, and the right caudate nuclei was 9.9% larger compared to the left. And finally, both right and left hippocampi were substantially bigger than the average adult males. What he got out of this was that even though the gross morphology of the brain didn't express substantial differences, the MRI and other advanced technologies revealed atypical structural and chemical imbalances that may be involved in the special skills of the 63-year-old savant. Though it's hard to make any generalizable theories out of this research, it is safe to say that Ramachandran was definitely on the right track when he said that other parts of the brain would compensate damaged areas of autistic and or brain damaged people who have turned into savants. In his final statement of his paper, Corrigan has said that the multimodal imaging approach presented in the study is suitable for the evaluation of larger samples of savants with a diverse range of talents to investigate common brain functions that may underlie the exceptional cognitive capabilities characteristics of the savant syndrome, given the high co-occurrence of the two syndromes, elucidating the underlying neurophysiologic basis of savant syndrome may also lead to a better understanding of autism spectrum disorder. That being said, it's safe to say that we definitely need more research on this topic before we can come up with any generalizable data. To conclude my presentation, it's safe to say that we cannot generalize cerebral differences between savants and normal humans, being that we have such a low amount of data coming in through magnetic resonance imaging. Also, I couldn't quite gather from research that the angular gyrus was directly connected to savants' brains from current research. However, Ramachandran was not incorrect about his predictions, being that he did predict correctly that the brain would essentially remap itself to compensate in larger quantities and areas of the brain in order to make up for whatever has been lost in the brain. Thank you for taking the time to listen to my presentation.